now that we can raise exceptions, we need to be able to handle them. And we do that with a try statement. So a try statement handles exceptions. It has the following syntax. First you say try. That's the whole header line that begins the statement. Then a try suite can contain arbitrary statements, which get executed. Now, during the course of executing the try suite, it could be the case that something goes wrong, that an exception is raised. And therefore, control may be transferred to the except suite based on whether this try statement handles the kind of exception that was raised, which is determined by the exception class. So here's the whole execution rule for this statement. First, we execute the try suite. If nothing goes wrong, that is, no exceptions are raised, that's all we do. But if, during the course of executing the try suite, an exception is raised that is not otherwise handled, and it's the case that the class of the exception inherits from the exception class that's given in the except line, then the except suite is executed with name bound to the exception, and we say that the exception is handled, meaning that your interpreter won't halt. Instead, you'll just execute that except suite, which does whatever we want it to do in exceptional circumstances. Okay, so that's how we handle exceptions, is with a try statement, and this can prevent our program from terminating. So for instance, I can write the following try statement. Try to bind the name x to 1 divided by 0. What will happen when I divide 1 by 0? I'll raise a zero division error. So I'm going to have an except clause in my try statement that says when there's a zero division error in the try suite, which is up here, then I'm going to handle it and bind it to the name e, at which point I will print handling a and then the type of e, which will be a zero division error, and then I'll bind x to 0. Now, why might I do this? Well, x will never be bound up here because the error occurs when we're in the middle of executing the assignment statement, when we're still in the process of evaluating what's on the right-hand side. So this is a very typical pattern that when we're trying to bind a name to a value and it doesn't work out, we're going to bind the name to some default value instead. That's not required. It just sometimes makes it easier to program, because then we know no matter what happens, x will be bound to something after this try statement is executed. Okay, so we execute it, and it prints out handling a zero division error. But if we look at what x is bound to now, it's bound to 0, and that's because of this line. Okay, so there's the first example of just the simplest try statement we can come up with. You can have multiple try statements in your program. They can be nested within each other. And what happens when an exception is raised? Well, control jumps to the except suite of the most recent try statement, so the innermost try statement that handles that type of exception. Let's look at a demonstration. Okay, so let's define a function called invert, which takes in a number x, binds y to 1 over x, prints a message, never printed if x is 0, and then returns y. Okay, so that's what inverting does. If we load this file and we invert to, we'll get 0.5, and this is printed because x is not 0. But when x is 0, then we raise a zero division error, y is never bound, and the print statement is, this print expression is never evaluated, and so we never print anything at all. Okay, and then let's also define invert safe, which will handle all zero division errors. So it takes in x, it tries to return invert x. if it's the case that there is a zero division error, we will handle it. So the except line says we're handling zero division errors. What shall we do? Well, let's print out that we handled it, and let's return 0. Okay, so now we can invert safe 2. And what will happen? Well, invert safe will call invert. Invert will compute 0.5. Print out, never printed if x is 0. Return 0.5, which is returned from invert safe. And nothing ever happens with the except part because there never was a zero division error or an error of any kind. But what happens when we invert safe 0? Well, this is never printed because even though we got all the way down here inside invert, we raised in exception. That exception was handled here. We printed out the fact that we handled that error, and then we returned 0. And why does it say division by 0? Well, that's the message that you get in a zero division error, division by 0, right there. Okay. So there's a basic example. Let's look at some slightly more complicated examples and see if we can figure out what Python would do. What would Python do? So here's the same program, except instead of y, I used result this time. And invert safe is slightly different because it's just going to return a string version of e instead of returning 0. Same thing. Okay, so what happens if I invert safe 1 divided by 0? Well, what's going to happen is that before we ever even call invert safe, we figure out what we're calling, and then we evaluate the operand to figure out what we're calling it on. And what we're calling it on doesn't have a value, because dividing 1 by 0 here will raise a zero division error. So this try statement is never executed because this function is never called, because before we ever have a chance to call it, we already have raised an exception. So the answer is invert safe 0, 1 over 0 will raise a zero division error. We haven't handled that case. Okay, what about try invert safe 0, accept zero division error, and print handled? Let's try it out. So we're going to try to invert safe. We're going to handle a zero division error. And we'll just print out handled. We execute that try statement. It doesn't say handled. Notice no exclamation mark. Instead, it just says handled division by 0, which is what we get from this line. When invert safe handles this exception, the exception is gone. It's already been handled. And so it's never raised to this outer try statement. So this one is outside of this one, because this line try was executed before this line try. Because we first execute this try, which means we call invert safe, and invert safe has its own inner try statement. What about invert safe 1 divided by 0? What sort of problem does that cause? Well, we should have another zero division error, right? Not quite. If we invert safe 1 over 0, then what we get is a name error, because the operator is evaluated before the operand. So we never even get a chance to divide 1 by 0, because we've already failed to figure out what invert safe means.